this video, we're going to find the coordinates of the special angles on the unit circle. I've already labeled pi over 4. I did that in most of my classes this week. If you didn't get that one, hopefully it'll make more sense to you after we do some of the other angles. So let's do pi over 6. Whenever we're trying to find the coordinates, right now we're thinking about a triangle. So we can remember that this comes from the thing I've shown you a few times about the triangle going around the circle. This triangle has a radius or a hypotenuse, which is the radius of 1. The base is x, and the height is y. Just looking at it to kind of give ourselves an idea of where we think the coordinates might be, we can see that x is more than a half. It's pretty close to 1. And that y, if we go along the y-axis, is about halfway. So honestly, I would venture to guess that the y-coordinate might even be exactly a half, but let's actually do the work and find out. So if we actually draw this triangle, and I'm just kind of pulling it out from the circle so we can look at it a little bit better. This is x, this is y, and this is 1. This angle right here is pi over 6, commonly thought of sometimes as 30 degrees, although I want to start thinking about it as pi over 6. There's a couple different things we can do here. We can go to these special right triangles, and we can look at the sides, making the hypotenuse 1, see what it makes the other two sides. I like to use sine and cosine, just my preferred method, not any required method. So that means that the sine of pi over 6, I'm only using sine first because it just came into my mind first, would equal the opposite over the hypotenuse. The opposite is 1, y, and the hypotenuse is 1, so that would be y over 1. Y divided by 1 is y. And the sine of pi over 6, this is where things get a little crazy. People put it in their calculator. It might not give you an exact answer. But if you remember when we did the special right triangles, we made this table, and the sine of pi over 6 is 1/2, which was our guess. So it seems like we were probably on the right track. To find the other side, we would use the cosine. So the cosine of pi over 6 would give us the adjacent over the hypotenuse, and the adjacent side is x. So x divided by 1 is x. And the cosine of pi over 6 we can find again on this table. Here, pi over 6 here. Cosine is the square root of 3 over 2. If you were to grab a calculator just to estimate the square root of 3 over 2, it's about 0.86, which fits in with what we thought, more close to 1, 0.86. So the coordinates here, the x comes first. That's the longer side. That's the square root of 3 over 2. And then the y coordinate is 1/2. From here, we actually don't have to do any more of this right triangle trigonometry. We can see that this triangle over here is the exact same as that triangle over there. All that happened is we mirrored it over the x-axis. So we can find the coordinates by making the x coordinate negative, and the y coordinate stays exactly the same. It's still the positive. So we have negative square root of 3 over 2 because we went to the left first, and still with a positive 1/2. I'm going to leave it to you to find the coordinates of 7 pi over 6, which is the same triangle just flipped upside down, and 11 pi over 6, which is again the same triangle as the first one, just flipped upside down. So the numbers will stay the same in the same order, but all that we've done is move it to the other quadrants. Now let's look at pi over 3. So that triangle looks like this that I'm doing in blue right now. And it turns out that this triangle is actually the exact same triangle. So pi over 3 is 60 degrees. So if you had pi over 6 in a triangle, 30 degrees, and pi over 3 in a triangle, 60 degrees, that is because it was a 30, 60, 90 triangle. So, let me make sure. If this angle is pi over 6, that means this angle up here is pi over 3. And once again, that's because if you have pi over 6 is 30, so if you have 30 degrees in a right triangle, then the other angle is pi over 3, which is 60 degrees. So this is the exact same triangle. The only thing that we've switched now is we've put it on its side. So what was y in this triangle is now x in this triangle. So we've just spun the triangle around. So now the coordinates are 1/2, comma, the square root of 3 over 2, because we've just turned the triangle. You also could do the same method we did here. You could take the sine of pi over 3 to get y over 1. But remember, the sine of one angle is the cosine of the other angle. So if you do that, just like we see in our table, pi over 6, when we're at 30, we have a half, and 3 over 2, we have 60, they work backwards. So we've switched which angle we're using in the triangle. So we switch which one is sine, which one is cosine. We've switched which one is x, which one is y. Similar to what we did with the pi over 6s, we can now do that for the pi over 3s. So that triangle that's in blue in the first quadrant is the same as this triangle that is in blue on the second quadrant. All that's happened is now x is negative 1/2 and y is positive square root of 3 over 2. I'm going to leave it to you to find the coordinates of the angles in the other two quadrants. Again, you can see it's the same triangle. It's the same as the green triangle turned on its side, or you can just think of it as once you found the blue triangle, all these blue triangles are the same, just spun around. So the coordinates will change. From there, you should have everything with a pi over 6 and a pi over 3. As I said, we did pi over 4 in class. I'm going to leave it to you. You could draw the triangle and do the exact same steps in order to find 1 over the square root of 2 and 1 over the square root of 2. Make sure you've convinced yourself that those are the numbers. Then you'll be able to find everything with a pi over 4. Finally, all that's left is along the axes. And these ones don't even need a triangle. Sometimes we forget because they're honestly just what we've learned about coordinates. If we start here, this one is at the point 1, 0. I don't need to do any work to find that. I just went over 1 and I didn't go up and down at all. And this point right here is at the point 0, 1. I'm going to leave it to you to find pi and 3 pi over 2.